So with quality and testing, why is is it important to ensure? Is ensuring software quality is hard. It's not easy for us. So software defects are everywhere. You can always find software defects, and you cannot just add quality at the very end. It must be built into process from the start, meaning that you cannot build a structurally weak house and try to fix it by painting the walls. So you have to start from the beginning. The structure is a problem. Why are there errors in software? While bad code causes them directly, the deep root cause are usually failures in management, processes, and documentations. So if you have problems in management, if you had problems in processes, if you had problems in documentation, these are the real root causes why there are errors in software. The example could be that a developer writes a bug, for example, because the manager gave them a confusing, incomplete requirement document. Because the requirements were not clear, it was confusing, it was incomplete, and that's why the developer writes a buggy program for it. Now, what is the Ariane 501 example? It was a rocket that exploded because it reused old Ariane 4 code with unverified assumptions, destroying millions of euros. So putting a lawnmower engine into a sports car without checking if it can actually handle the speed. That's the same thing, right? If you just do something that you are not sure about, then it would eventually just not work out perfectly. Now, what caused the Ariane 501 failure? It failed due to a math conversion error, missing an exception handler. That was the root cause. Rooted in undocumented assumptions that nobody tested. So nobody tested it and nobody documented it as a problem. And because they were undocumented assumptions, then we just go root back to the same thing, just like we said, that either there's a problem with management, a process, or a document, something that supposed to be documented and was not documented. Then which quality assurance measures could have prevented Ariane 501? It could have been saved by 6 measures. First of all, cost management, strict reuse inspection, clear specifications, and complete error handling, and realistic system tests and expert reviews. Based on these 6 things we mentioned, it would have been possible that we did not encounter this. If an expert had simply reviewed the old code against the new rocket physical specs, they would have spotted the math error instantly. So they would know that this new will not work perfectly on the new hardware. What is quality management? It is established process of describing, evaluating, achieving, and finding defects to handle overall software quality. For example, it is a company-wide blueprint. It's a blueprint, it's like a template maybe, that dictates how every single department works together to make a good product. This is what quality management is all about. It's like establishing, describing, evaluating, achieving, and finding defects to handle overall software quality. Now, what is quality assurance? Quality assurance is concrete procedure. It's like a concrete procedure for ensuring quality, split into 3 types: constructive, analytical, and organizational. So these are the 3 types we can link back to. For example, quality assurance is the actual daily work, like running automated tests, analytical, or enforcing coding standards, which is constructive. So either one of these. Can quality be tested into a product? No, you cannot just test quality into a product. You must build it in using organizational and constructive measures first. For example, tasting a burnt cake over and over won't make it taste better. So you have to bake it correctly from the start. So for example, if you taste a cake that is burnt, it's a burnt cake. Let me look at it. If it's a cake that is burned, you test it again and again. If you eat it again, it's not gonna make the cake taste better the next time, and that's pretty obvious. So how do reviews, static tests, and dynamic tests differ? Reviews are done by human readings. Static tests use a computer to analyze without running the code, and dynamic tests actively execute the code. Meaning that reading a recipe, this is a review, using spell checker on it, this is static, and actually cooking the meal, this is dynamic. So just like we see that our use a computer to analyze without running the code. So it's a spelling checker. It's static and then actually running the code or actually running it to test. Why do you test? The primary objective of testing is to find errors. So a crash test dummy is put into a car specifically to find out where the car breaks. Now, what other test objectives exist? Other goals include checking requirements, for example, verification, ensuring usefulness, which is validation that can it even be used. This is very important. Checking requirements, did what we were supposed to do, that's verification. Ensuring usefulness, can it even be used? Does it even work? That's validation. Building trust, assessing risk, and providing legal conformity. Testing a medical app to ensure it mathematically complies with health privacy laws, for example. Now, define test failures, defects, and errors. ISTQB ISO 24765. This is an error. An error is a human mistake which creates a defect in the code, which causes a visible failure, and testing is the process used to find them. For example, a tired coder types a minus instead of a plus. This is an error, leaving a bug in the code. This is a defect. So two different things, which crashes the app when the user clicks buy. This is a failure. So we know there are different things. For example, an error is a human mistake. This is what the human did, which creates a defect. It creates a defect which causes a visible failure, and testing is the process used to find them. So testing is the process that we use to find them. Now, a customer reports a problem. Is it a failure or defect? It is a failure because a customer only sees visible crash. He doesn't see the defect. The hidden code problem causing it is the defect. So a user reports screen went black. This is failure, but they don't know what was caused by the null pointer exception in the code that caused this, which is the defect. Now, what does a test case contain? It contains a name, the tested requirement, preconditions, postconditions, specific test steps with expected results, and the needed infrastructure. For example, login test, start on login page, this is precondition, enter admin and 1 2 3 4 steps, or expect welcome screen, this is the result. Now, logical versus concrete test cases. A logical test case uses broad value ranges like an empty list, while a concrete test case uses exact specific data like a list with person X. Let's look at an example. Logical is enter any negative number. Concrete is enter exactly minus 42. So these are logical test cases and concrete. Logical test cases that enter any negative number, for example, and a concrete test case is that enter minus 42. Now, positive versus negative test case. A positive test case checks if valid input works correctly, while a negative test case checks if invalid input triggers the proper error handling. So if I did something that I was not supposed to do, it is supposed to do, oh, wait a minute, that's just not possible. This is negative testing. Positive is just if valid input works correctly, if it's doing what it's supposed to do. So positive is like typing a correct password to login, while negative is a typing drop table to see if the system safely blocks it. I think this might not be a perfect example, but just like I mentioned that a positive test could be, is the password even working or telling us to log in to the system? It is supposed to work that way. Is it working the way it was supposed to work? And then the second negative test is like, if I type something that's not really a password, or I try to make a new password for an account, it should tell me that you cannot make a password that's shorter than three letters. So the first thing is that, does it even let you make the password? Yes, that's possible. But what if I do something that's out of the box? Something that's not, so for example, opening the app, closing the app 5-10 times. And this is out of the box, nobody does it. But it is supposed to still at least give an error message or tell you that this is not allowed. That's negative testing. So who tests? Everyone is testing. Every single team member responsible for quality. Example, even the product manager tests by reviewing the final UI to ensure it matches their initial vision. So what does the psychology of testing tell us? Humans are naturally blind to their own mistakes and heavily biased by their expectations. So they think what they did is very good, making it hard for them to test their own work reliably. An author reads their own book will easily skip over typos because their brain already knows what it should say. So it's very obvious that everyone is testing, and it's really important. This is the psychology of testing. How do you minimize your own test bias? You use pair programming, you test driven development, or have another person review your work. So you can use pair programming, then you can do test driven development, writing test before code, or have another person review your work. For example, having a coworker try to break your login screen because they will try weird inputs you never thought of. So this is the thing. When do you test? You must test always and continuously, because finding a defect early makes it far cheaper to fix. Fixing a typo on a blueprint is free, but fixing it after the building is built cost millions. Now, what are the test levels? The levels go from below to top. So unit test, integration test, system, and acceptance. So it goes from below to top, down to up. That unit test meaning single parts testing. Integration test means parts working together, if they are working perfectly together, first individually, then together. Full system, full workflow, so the whole system. And acceptance, customer approval, does customer approve it? Testing single gear unit, testing the engine, integration, testing the whole car system, and the customer test driving it. So customer, you can give a test drive to customer, and that's acceptance. How do you test? You test systematically using a clear goal and a solid plan, never just guessing. So following a strict checklist of 50 login combinations instead of just mashing the keyboard. So you don't just mash the keyboard and see if I'm testing. That's not, it's a calculated process that I'm following a strict checklist of 50 login combinations. That then we go with black box versus white box test. So black box testing means checking the system without knowing its internal code, while white box testing uses full knowledge of the internal logic. These are the two differences between a white box and a black box. So black box is like guessing what's in the locked safe by shaking it. So we're just guessing based. It's a locked safe. We don't know what's inside of it. It's locked. It's a safe. We move it and shake it to guess what's inside of it. White box is like looking at the safe open blueprint. So it's open now. It's like testing full knowledge with internal logic. Now, how much do you test? You test just enough so that the software can be delivered with acceptance known risks. You don't need to test a weather app 10,000 times a day, but you do for airplane navigation software. So it depends on the acceptance risks. If there is a high risk involved with it, then the testing increases. What is a test specification? It is a documentation that records the logical steps, concrete data, preconditions, expected results, and the final pass or fail outcome. So a spreadsheet where testers put a green check mark next to password reset works. So password reset does work. So it's a document that records logical step, preconditions, results, and final passed fail outcome. What does an error log contain? So it's a Spillner or lints. It contains a reference to the fail test, the specific data needed to reproduce the crash, and a severely classification. So fail test number 4, entered password ABC caused server crash severity 1. So entered password ABC, whatever you entered, it didn't work and it failed, and it caused, why did it fail? Because it caused server crash, crashed the server, and you log it basically. What are error severity classes 1 to 5? They rank from worst to least. Class 1, crash, the whole crash. Class 2, critical failure. Class 3, normal deviation. And class 4, small issue. Class 5, cosmetic error. So a deleted database is class 1. So the whole database is deleted, while significantly misaligned logo is class 5. It's just cosmetic error. It's not like cosmetic wear and tear. It's not where it's supposed to be. It's just not on the. Class 4 is a small issue. Class 3 is normal deviation. Class 2 is critical failure, and class 1 is complete crash. What is test protocol? Spinner lints. It is summarized report showing exactly which tests were run and what errors were found. used as a basis for customer acceptance. So the final PDF report handed to client proving 99 out of 100 features passed perfectly. So this is important for that. Then we can say, okay, we did 99 out of 100 features, they pass. Now verification versus validation. Again, verification checks if you built the system right, machine matches the requirements, while validation checks if you build the right thing. So did the right thing. So verification is like we build the system right in the right way. If you build the system right to match the requirements, that are we supposed to doing what we're supposed to doing? Is it right? While validation checks if you built the right thing. Is it actually useful? Like, can you even use it? Is it something that you can drive a car with? I was supposed to make a car. Did I even make a car? That's verification. That, oh, I'm supposed to make a car. Is it even a car? Yeah, that's verification. Validation is that, does it even work? Can you drive with it? So a mathematically perfect umbrella with giant holes verifies the design specs, but fails validation because it doesn't stop rain. So validation is purpose-based. Its purpose was to stop rain. Does it even serve its purpose? That's validation. Verification is that we need to make an umbrella, or how does it look like? This is verification. How does the container example illustrate this? Build a plastic blue 10-tire bucket proves verification. Checking if it actually holds water without splitting proves validation. Like, is it even doing its job? So the blueprint said make a bucket, verification, but the user wanted to carry water. That's validation. That's what the user wanted. User wanted to carry, though if cannot do what the user wanted, we cannot validate it that it's doing what the user wants. Verification is something wants it to do in the end product. That, is it even doing it? Is it even running? So I have a car. I'm supposed to make a car. A car has 5 holes in it, or maybe the engine is not working at all because of the holes in the engine. So of course I did make the car. Am I supposed to make a car? What am I supposed to make? Make a bucket. Just go ahead. Is it even, I'm doing it? But then you need to really make sure, is it even working? And that working thing is validation. Now, how does the usability example show? It shows that even if a system failure perfectly passes its functional requirement, it might still be too hard for humans to use, which is validation feature. Example is that an alarm clock that requires solving calculus to set the time is functionally perfect, but it's completely useless. So if I have an alarm clock that requires solving calculus to set time, I mean, it does work, but it's completely useless, because then what is it? Why do we even need a clock for when I can do that work myself? When I'm doing all of the work. So it's completely useless then. This is why validation is a feature, that is it even doing its job, what I needed from it as a customer. So what are Nielsen's 10 usability hierarchies? They are 10 rules for good design: feedback, metaphor, navigation, consistency, error prevention, memory recognition, efficiency, minimalist design, error recovery, and help documentation. So a trash can icon, which is metaphor, that asks, are you sure? Error prevention before deleting a file. So this is a trash can icon, which is a metaphor. When you delete something, it says, are you sure? Which is error prevention before deleting a file. So what is a review? ISTQB. It is a type of static testing where actual human beings evaluate the quality of a work product. 3 developers sitting in a room reading over a colleague's code print out to find logic errors. This is real review person reviewing it, actual human beings evaluating the quality of a work product. So when is a review useful? Reviews are always useful, especially right before project milestones, phase handovers, or showing work to a customer. Double checking your presentation slides right before walking into the client meeting. That's exactly when it's useful. So who carries out reviews? Everyone carries out them, because every team member shares responsibility for quality. A junior developer can review a senior developer code to catch silly typos. Now, why review and test early? Finding a defect early makes it significantly cheaper and easier to fix. For example, erasing a pencil line on a blueprint takes 2 seconds. Tearing down a brick wall takes weeks. So this is why it's better that you just do it even before it gets to a big problem. What is the rule of 10? It states that the cost of fix a defect multiplies by roughly 10 at every single stage of development it passes through undetected. That's a rule of 10. A bug costs €1 to fix in design, €10 in coding, 100 in testing, and 1,000 if the customer finds it. So it's better that if you find it early and you fix it, that's better. If you find it later, the moment the customer finds it, it's gonna cost you way much more. So it's different stages of development, pass it through undetected error and not fix it. So a bug can be fixed in the design phase, in coding phase, in testing phase, and also when the customer himself finds it, but it's different how it costs you. So it's a rule of 10. 10, multiples of 10. You multiply that by 10. Every digit, you multiply 10 by 10, you get 100 in testing, 1,000 in customer finds it. So that's where you say that it states that the cost of fixing a defect multiplies by roughly 10 at every single stage of development. It passes through undetected. How do you carry out reviews? You do them systematically using methods like checklist-based, role-based, perspective-based, or a mix of formal and ad hoc reviews. Giving a tester a specific 10 points checklist so they don't just guess what they should be looking for. So it's a 10 points checklist where they don't have to guess what they're looking for. This is how you can carry on reviews. These are methods like checklist based, just like I said, role based, perspective based. Different roles have different expectations, perspective based, and a mix of formal and everything. Now, what does a review documentation contain? It contains the checklist used, a description of the formal processes, and a final protocol summarizing all findings and evaluations. So a meeting minute document that lists the 4 bugs found during the code review session. This is a minute meeting document that lists the 4 bugs found during the code review session. This is what the review documentation contains. Now, rules for formulating review findings. Write findings neutrally, classify their severity, how severe they are, critique it, the artifact, not the person, of course, and always leave room for follow-up questions. Saying this function crashes when given a 0 instead of saying you wrote terrible code here. So you should say that this function crashes when you give it a 0. That's how you formulate review findings instead of saying that, hey, you just wrote terrible kind of code. That's not right.